Hello, I welcome you all to this another interesting screencast, and the problem reads: the pipe assembly is subjected to the 80 Newton force. Determine the moment of the force about point A and about point B. This problem is coming from the Engineering Mechanics and Statics textbook, 13th edition by R.C. Hibbeler. We have been asked to determine the moment about point A due to the force 80 Newton. Right, first things first, let's identify the moment arms. From A, we're going to have one moment arm to the line of action of the force, which has some information, and we are going to direct it to that point C. So we'll call this as RAC, and since A is our reference, we can also just call it as RC. Okay, and then we also need another one. We also need moments about point B, so we'll have another moment arm from there to the line of action of the force, which will also be the same point C, and then we'll call this particular moment arm as RBC. Okay. Let's identify the coordinates for C. Since A is just 0, 0, 0, B, we have the coordinates in the X. That's 250 plus 500. I'll convert it to meters. That's 550, so it's 0.55 in the X. And then in the Y, the dimension is 400, which is 0.4. And then in the Z, it is 200, therefore convert it to minus 0.200 going down 0.2. And then the coordinates, this is the coordinate, coordinates for B. I was writing the coordinates for C. The coordinates for B, we have only in the y-axis, which is just converting them to meters, is 0.4. In the X, we have 0. In the Y, we have 0.4. And then in the Z, we have 0. Then C, this is the one. Okay, C, in the X, we have 250 plus 300, which is 550. Therefore, we have a 0.55 in the X. In the Y, 400, which is a 0.4. And in the Z, 200 going down, which is minus 0.2. All right. Then the position vector RBC can even start with RC. RC, therefore, it is just 0.55I plus 0.4J minus 0.2K. Then RBC, this is going to be equal to C minus B. C minus B, this becomes just a 0.55I. 0.4 minus 0.4, just a 0. Then minus 2 minus 0, this is just a minus 0.2K. Alright. Then what are the components of this particular force? Let's find it. So this force will have a component along this direction here. Here it will be mapped up like so. Okay, so we'll have a force in that direction. So we are mapping this force there like so. Alright, and this component is going to be equal to F. Okay, this is F cos 30, and then we'll have another component. This same component will be mapped on the y-axis like so. So we are mapping it like so. So we are mapping this like this, and this is equal to F cos 30 cos 40. Okay, and then we'll have another component that will be mapped down. I'll use black to be mapped down. Okay, this is the y-axis, and then let me map something on the x-axis before I go down. So I'll have something also that will be mapped in this direction, to be mapped in this direction from that point. Okay, to be mapped in that direction. This one is going to be equal to, this one will be equal to F cos 30, then sine. So we are mapping the same one. It's the same one we are mapping. We are mapping this like this. Okay. Then sine 40 degrees. Okay. Then we'll have one mapped downwards. What color can I use? I can use red. Down like this. Like this. Okay. This is mapped downwards. This one is equal to, we are mapping this. We are mapping this. This one, where is it? We are mapping this like so, and this is equal to F sine 30 this is equal to sine 30. Okay, yeah, right. So we are done. So we can write these particular forces now as a vector quantity. Let me just create a boundary here. I create a boundary, something like this. Okay, there we go. So we have everything that we need. So let's write down the force. Our force is equal to, component in the x, which is equal to F, which is 80, cos 30 positive sine 40 I. Then in the y is also positive. It is 80 cos 30 cos 40. And then in the z-axis, it is negative 80 sine, forgotten to put a j there, then minus 80 sine 30k. So rewriting this, simplifying it, we have 80 cos 30 sine 30 sine 40. This is a 45.53 I. Okay, 80 cos 30 sine 40. Okay, then we have 80 cos 30 cos 40. So this becomes plus 53.07j. Then minus this one, just a 40. Sine 30 is 0.5. Okay, so we are done with the force. So let's go to the first case, case 4-14. What do we have? Of course, we need moment about point A. So we'll say moment about point A is equal to RC cross F, and this is going to be equal to IJK. Alright, so RC, we said RC is equal to 0.55, 0.4, and minus 0.2, and F is equal to 44.53, and then we have a 53.07, and then minus 40. This is equal to I, we have minus 40 by 0.4, then minus 0.2 by 53.07. So it gives us minus 5.39. Okay, minus 40 times 0.4, then minus 0.2 by 53.07, 5.389. Okay, then J, minus 40 by 0.55 minus minus 0.2 by 44.53. Okay, so this gives us a minus 13.09 plus, let me check this, J minus 40 by 0.5 minus 0.2 by 44.53. Okay, then for K, we have 53.07 times 0.55 minus 0.4 by 44.53. Okay, this is 11.38. Alright, so moment about MA is therefore going to be equal to minus 5.9 I plus 13.09 J plus 11.38 K, and all this is Newton meters, and the magnitude of this, you can calculate it. Magnitude of this is 5.39 squared plus 13.09 squared plus 11.38 squared. Okay, so this gives us 18.16 Newton meters. Okay, 09 squared plus 11.38 squared. Alright, so we are done with the first case. Let's go to case number 2. Case 4 dash case 4 dash 41. Alright, so there we are. We have been asked to find moments about point B. So say moment about B, they are like so. This is equal to RBC cross F, and then this is going to be equal to, we have I, we have J, we have K. Okay, RBC, we said is 0.55, then J is 0, then minus 0.2. Then the force is the same, so 4453, then 53.07, then minus 40. Alright, then we have I, so 0.2 by 53.07. Okay, so this is a plus 10.61 minus J minus 40 times 0.55 minus minus 0.2 by 44.53. So this is minus 13.09, and then plus K 53.07 times 0.55. This gives us a 29.19. Alright, therefore at the moment about point B is going to be equal to 10.61 I plus 13.09 J plus 29.19 K. Okay, and the units for this moment is Newton meters, and the magnitude of this moment is equal to, use your calculator using Pythagoras, 10.61 squared plus 13.09 squared plus 29.19 squared. So this gives us a 33.70 Newton meters. Alright, let's outline the final solutions. We have the summation of moments about point A. There we go. Okay, and then we have the summation of moments about point B. There we go. Okay, right. I think this is about it, and I hope the video was helpful, and if it was, give a thumbs up, like my video, continue subscribing and liking my channel. Bye bye, and see you in my next screen.